Actually talk about how we code a LIFO algorithm. Let's have a fresh sheet of paper and talk about this. So LIFO, what we really want to do, and the idea of encoding an algorithm, is that the algorithm should provide us with a skeleton of how the code works, so we don't end up adding variables where we don't need them. So we've got something like this, as we've said. There's our stack. I'm thinking it always as a stack of plates on a table. Okay, so last in adds to the top. Okay, so that's what the push does. And as we said, the pop goes to the top and removes it, the top item. So that's what the logic is. So when you're coding it, okay, you need to decide, how is this whole logic going to work so it sticks to the LIFO algorithm? So this then provides you with a different kind of way of approaching it. And what I would suggest when you think about it is to ask, well, you know, if I'm joining upwards, right? So their node there is joining to that node is joining upwards. Okay, let's just think through what would happen when I push a new item on. So when I add a new plate on top, I take the previous top item and then I link it to the new one, okay? And then I set the top node inside my stack. So if I'm going for the top node here, I set that to the new stack node or plate, right? Because I'm thinking of it plates, or they even look like pizza trays, don't they? Okay, so that's what I would need to do. Those are the steps I would need to code it. I would need to take the linked item for the top and set it to the new item, right? So I'd have to do some work on the set linked for the current top. I would then have to set the top node would have to be my new one, right? And I'm just sketching it here. So that's if I approached it up, downwards, upwards. And so I'm storing perhaps the first node here, okay? Now the alternative was to actually make the links go downwards. So if that's the top one, it links down to the item below it. That one links down to the item below it. And the one right at the bottom links to nothing. So if that's my approach, if I push onto another item, the first thing I would need to do is link that node to the previous top. So I'm using a set linked again. So, you know, very similar to the other one, right? But I'm linking it to the current top rather than the other way around. Then I'm setting the top to the top item, right? So the top equals the new node. So superficially, the code in these two approaches looks almost identical. That's why it's really important for you to work out which keeps the spirit of the LIFO algorithm most true. Starting from the bottom, linking upwards, starting at the top, linking downwards. So that's your challenge, I would say, here.